Now you may remember that many times big storms are, I just suspect in this case, this storm was caused by a cold front. You may remember a cold front, you have a cold mass of air that is moving really quickly into a warmer mass of air. And what that does is it makes a lot of hot air rise. And whenever that hot air rises, it's going to meet the dew point. And in this case, the dew point was pretty low, right down in here. And since you continually have hot air rising, it forms these enormous clouds. I mean, look how big this cloud is. It goes out of the picture and all the way over to the top. That's a lot of hot air that has risen. And these are the kinds of clouds where you get thunderstorms. Now, here's the reason why. I've mentioned this before in class. It goes up so high that you have ice that actually forms in the very top portions of it. Now, what happened, we want to figure out how lightning is formed. Because you don't have lightning with every little old rain, but when you have lightning, it's going to be with these huge clouds like this. And it's because of the ice. It's because of the ice that is right up at the top here. Now, this ice is going to fall, but it's so small at the point it's made that the rising air can lift it back up, and it fall and lift it back up, and fall and lift it back up, and it kind of creates an electrical charge with the rising and the falling of the ice. Now, this electrical charge you'll see on another diagram has like pluses and minuses, but I guess you can kind of think of it like rubbing your feet on a rug. This up and down motion is kind of creating a little electricity, and that electricity, whenever it reacts with the ground, I think this may be a better one right here. Whenever you get this static charge here, you have these negative charges that react with the positive charges from the ground. Now, I know that's a little heady right there, but just know that the falling up and down of the ice, falling and rising of the ice and water particles is what causes that. It's like static electricity. And as you know, you can have some incredibly hard lightning strikes. Now, lightning, whenever it hits the earth, is actually hotter than the sun is, from what your book says, and it just really produces a huge bolt of heat. Now let's take a look at this lightning strike over here. We have several strikes over here. The huge cloud, probably have the cold front over here, warm air which is going up, warm air which is going up, and you can see it kind of goes even past this first little cloud into this big cloud right here. Notice where the lightning strikes are coming from. They're coming from way up top. They're not coming from just right down below. They're coming from way up top where that ice is going up and down. But anyway, what's happening here, with every lightning strike, you have the thunder. Now, I mentioned that these lightning strikes are going to be incredibly hot. As your book says, even hotter than the sun is. So what you have happen is it sets off this very fast wave of heat in every direction. And sure enough, I forgot to put the marker thing on. But it sets off this wave of heat in every direction. And even though it's not something that we feel as much as we hear, that wave of heat and the clap that produces from it is what we get the thunder from. So you don't hear thunder unless you have some kind of lightning, cloud to cloud or cloud to ground lightning. Now we're going to have something called a downdraft. Now, have you ever been out and the rain coming down just incredibly hard? Whenever you have incredibly hard rain, it's often from a downdraft. The downdraft comes because you have a lot of hot air rising, and you can see this diagram, it goes right up through here, throughout this cloud, and whenever you have these pellets of ice falling and going up and falling and going up, that kind of has a characteristic, it kind of has that pent up energy, and it comes down harder than it would have if it were just falling. And you've had rain that has come from clouds. It's just like a little sprinkle, and you've had rain that has really been a downpour. Downpours often come from down drafts. You have the up motion and consequently the down motion. Kind of reminds me of Newton's law. Every action, there's an equal opposite reaction. You really have these downdrafts that are hard. Now notice what's happening over here, and it's going to be in the other section too. You have most of the rain on a certain side. Not where it goes up as much as it is where it comes down. Same thing over here. I'll put it on a different something right here. You've got the updraft on this side, updraft on this side of the cloud, and you've got the downfall of rain coming down on the other side of the cloud. Now these downdrafts can have a lot of characteristics to them. They're whenever you have hail, it is often a result of a downdraft. Whenever you have bad thunderstorms, you often have a downdraft to it. Whenever you have a tornado, you have a downdraft to it. And we'll talk a little bit about tornadoes in just a second. Airplanes have to watch out for these downdrafts, because if an airplane is flying and you have this downdraft, suddenly it is pushed down, not to mention the rain that goes with it. So it's really a dangerous place to be if you have an airplane. Airplanes would try to need to go high as they can, I suspect. But anyway, here is a big wall cloud. You have a wall cloud when you have the up and the down. And you'd put it on opposite sides, but it could have been on either side here. You have the updrafts and the downdrafts, and it often forms these big old clouds called wall clouds. And yes, that is going to be a characteristic of a tornado. Now, every time you have one of these wall clouds doesn't mean you're going to have a tornado. Every time you have an updraft and a downdraft, it doesn't mean you're going to have a tornado. And every time you have a tornado doesn't mean it's going to be a bad one. But when you do have one, you're going to have the updraft, the downdraft, and a wall cloud to go with it. You may recall how rising air makes thunderstorms. Here you have a cloud just like you had before. You have the rising air up through here. You have the downdraft coming through here. Now what you have air going up fast, air going down fast. And it's kind of like if you, the book is going to say it's like if you take your hands and have them facing each other and put a pencil in between them. And you have the up motion and the down motion. The tornado is like the pencil that's in between. It twists because you have that up and down motion. And yes, if you don't have a downdraft, you probably don't have any tornadoes because you just have all the wind going in one direction. Now, if you take a look at this, this kind of indicates that it has a circular direction, which you know it could because the scientists are a little bit unsure of the complete dynamics of it. But they are pretty certain that because of that downdraft, it changes the dynamics of this updraft, and you can have your tornado in the updraft. You can see where you have the arrows coming in here, and you can see where they have the arrows coming in here, and off to the right here you can see tornadoes that are flowing. You have this funnel cloud, that's what it's called, where you have the downdraft tornado that is forming. This one hasn't hit the ground, this one doesn't appear to hit the ground, and this one doesn't appear to hit the ground, but it may be. The reason is because what you have here is twisting air, and you don't see air until you have some kind of debris or heavy amounts of vapor in it. And if you look closely right here, you can see that it looks like there's some kind of disturbances right here. So that is probably where this tornado actually is touching the ground. It just doesn't have enough vapor or debris with it to be able to see it. And all you see of this one is this vapor and debris here. All you see of this one is the vapor and debris here. Now, tornadoes can be very small, and most of them are. Most tornadoes last only a few minutes. Some tornadoes, like this one, don't even make it all the way to the ground. They end up coming up. Some tornadoes may touch the ground and then end up coming up. And about 20% of tornadoes are strong enough to knock over trees and to lift up cars. Very few tornadoes, however, are very violent. About 1% of tornadoes are violent enough to completely demolish sturdy buildings. And some of these very, very violent tornadoes may stay on the ground for 2 hours or more. And these are the ones that we hear about a lot. And here's some looks of some of them. Look how big this tornado is. I mean, it goes from here to here, and this is probably a good mile or two away from where this camera was looking at it, and it looks incredibly wide here. This is probably a mile or two wide, and if you're in the path of that, then you really need to take cover and just hope that you're not going to be in bad shape. Look how far away this is, and still you have so much of this tornado touching the ground. These are the kinds that last for hours on the ground, and anything in its path is very likely to be destroyed. And here's a big one right here. Lots of debris up in here. This looks like a very dark tornado. Now, here in Rome, Georgia, we've had tornadoes that have been nearby us recently. Here are some local tornadoes. This is a tornado that happened this year in Adairsville. You can see this tornado, Channel 2 News. I mean, they're the ones that happened to be there covered it, and this one happened this year. You can see this big funnel cloud right here. This is the tornado that came through Cave Spring on April 27th of 2011. This picture of it was where it was touching down at Tuscaloosa, Alabama at that day. This is one that stayed on the ground for like hours. Stayed on the ground and ended up making it all the way up to Cave Spring and even past that. Right down here is an apartment complex which was destroyed by this tornado, and the reason I put this particular one is way back about 20 years ago I used to live in this apartment right here, and I was just shocked to find out how my old apartment complex was completely destroyed by this tornado. And you can see there's nothing livable here now, and in fact this place right here was just utterly demolished as it went through. Tornadoes, these big track tornadoes can leave bad paths to it. I mean, look here. You can see exactly where this huge tornado went just by looking at the ground. This whole little section here, whole little community here was just utterly destroyed. And look here. I mean, you don't even know what these were here. All this debris right there. It's just really kind of sad to know that what could be a town at one point is moments later nothing. Now on radar you have a signature of a tornado. You have what's called a hook echo, and I have given you 6 examples of hook echoes here. And you can see what you have here. You have a big hook. You have a big hook, and the hook is right, well, I picked the wrong color to write on that. Let's do a blue. The hook is right here. You see where the hook is? Same thing here. The hook is right there. You can see a definite hook right here. Got a hook echo right here. Hey, this is Georgia. I see Macon. That's in South Georgia. And they're labeling the hook echo for you right here. And you got the hook echo right here. So that is kind of a characteristic that people are looking at whenever they have tornado possibilities. And finally, all tornadoes travel in the same direction. Take a look here. Here are, I think this was the track of the tornadoes on April 27th. Let me move this out and make this big. Yeah, every single one of them is traveling in the same direction. Every single one of them. This is the one that hit Cave Spring right in here, and it started even before it hit Tuscaloosa. Look here, just the whole entire way. They all go to the northeast. Every single one of them. Every single tornado you will encounter will go to the northeast. So what you do sometimes is you sometimes have plans to where you clear out the sections of a building that might be the closest to a tornado. You can kind of know which part of your house that a tornado would hit first if it were to come through. It would be the section that's facing to that is facing, oh, I can't even get this right, that is facing in this direction is the one that you do. Because I mean, look here, they're all going that direction. They're all going that direction. It's just the same thing the whole time. Well, I hope you learned a little bit about thunderstorms and tornadoes.